Welcome to the Next Level Human podcast. As a human, you have a job to do. In fact, you have 4 jobs: to earn and manage money, to attain and maintain health and fitness, to build and sustain personal relationships, to find meaning and make a difference. None of these jobs are taught in school, and that is what this podcast is designed to do: to educate us all on living our most fulfilled lives through the mastery of these 4 jobs. I'm your host, Dr. Jade Teta, and I believe we are here living this life for 3 reasons, and 3 reasons only: to learn, to teach, and to love. In this podcast, I will be learning, teaching, and loving right along with you. I'm grateful to have your company. Here's to our next level. All right, welcome to the show, everybody. This is the Next Level Human podcast. I'm your host, Dr. Jade Teta, and today I have with me Alex Martinez. He is the CEO and founder of Intrinsic Medicine and is doing some really neat things. I am going to say a little bit about why I became interested in him and really selfishly wanted him here to educate me on some of the things that he is doing. And so, As it normally happens, being a podcast host, you oftentimes get reached out by promoters and people who essentially have an expert that they're saying, hey, you might want to have this particular person on your show. And so Alex came across my desk this way, and I went and looked at what he is doing. And many of you who follow naturopathic medicine, functional medicine, know that one of the mainstays of our work is really around gut immune function. And so we have seen for a very long time, just as a reminder, I graduated from medical school back in 2004, started in 1997. And back then, no one was talking about the gut and the immune system, but we got that as one of our first courses. We learned, before our gut restoration programs, how integral the gut immune connection was. So it's been really neat to see this, especially over the last 10 years, everybody talking about this, influencers even talking about this. And I think Alex and his company are doing something really, really cool here. So Alex, the first question I sort of want to get into as we begin this discussion is, obviously Intrinsic Medicine is doing a lot around this recognition of gut and immune function. And you all are coming at it from a different perspective. And so what I want maybe to ask is how you came to this in general, and then what is it that Intrinsic Medicine is doing that's so different?
Awesome. Hey, thanks, Jade. Thanks for having me. Excited to speak to you about this. So it's a pretty fascinating story to some, but is essentially I came to this after a pretty different career path. Studied public health, was actually a corporate attorney, practiced in Silicon Valley doing med device work. And really the running theme in my life was I wanted to figure out a way to help people and without becoming a doctor. Tried that early in undergrad and it didn't work well. So took a health policy route, realized the legal education would be important to that, realized that the mere practice of healthcare law was actually perpetuating dysfunction in the system, recognized innovation as an opportunity. So I actually helped spin out a couple of companies when I was in law school, and then found myself at a premier group in Silicon Valley doing the most boring work for the most interesting companies. And so never one to sit still. I shortly started my first company, which was an MIT spin out, which was digital health. It was a patient education at the point of discharge company. We re-engineered the patient discharge experience. This is before digital health was even a thing. And paradoxically, I discovered at that time, the CEOs of hospitals loved what we were doing. We kept patients. We prevented readmissions. CFOs did not. They said, that's actually where we make our money from, right? And so what a striking fact pattern to be living. So moved on from that after drafting part of the Affordable Care Act that actually created the financial penalties for readmissions. So that was a parting gift, and was lucky enough to get a very unique role that I was grossly unqualified for. So I had to get it by actually doing a project for the company, but I got to run corporate development, competitive intelligence, and market research for a biotech company called Ionis that was developing mRNA targeting therapeutics. And so that was kind of my infiltration into biotech and my opportunity to learn the business at a key inflection point. Helps take Ionis from, a small cap company to a, over $10 billion company with 4 approved drugs, with really creating a third new drug discovery platform. And it was all about antisense targeting mRNAs, primarily for monogenic diseases. And this is when I learned something very interesting, that sometimes companies look at their toolkit and they say, oh, let's apply this to everything, including maybe some GWAS markers that are not monogenic, that the disorder is more multifactorial, and then risk-benefit really changes. So at that time, they were doing some cardiometabolic diseases, and I was like, I don't love this. And it turned out to be the neurology programs. And I got to work very closely on the program that was the first drug ever approved for spinal muscular atrophy. And that drug did have Lazarus effects. You could give it to babies early enough and they would develop normally versus, generally dying by the time they were 2 years old. So that was a privilege to work on that. But sort of right there in my mind the entire time as I worked at another program that I would say wasn't that great and actually had some very severe side effects is who's developing drugs for the rest of us? Because all of pharma was saying, let's focus on rare diseases because there's a wide leniency in terms of safety. And then everyone flips around and sells these drugs for $500,000 a year. And I'm coming from a health policy, a public health perspective. I'm saying this doesn't sit right. Not to say that rare disease patients don't deserve attention and efforts, but we have a chronic disease epidemic. And, what we've learned from the Human Genome Project is that genes are not deterministic. So myself and my co-founder, who also worked at that company, he was like me, somebody couldn't stick to their job description. He was a patent attorney, medicinal chemist turned patent attorney, turned running regulatory affairs for that same company. We recognized that the ultimate arbitrage opportunity in pharma would be safety. What if we could find truly safe compounds? And then we said, well, how do we stop siloing disease? And this is probably something that you talk about in your practice. Let's not silo diseases. Let's look at the common causal drivers. And we said, well, what's common to all these chronic diseases? And we're like, it's immune dysregulation and dysbiosis. And then, so you have that, and then you probably have a layer of genetic susceptibility and a loss of regulatory function from other environmental factors and lifestyle factors. And we said, okay, well, we just outlined a pretty compelling profile for something we'd want to do. It needs to work through those mechanisms and be absolutely safe. Where are we going to find it? How are we going to find it? And that's why I said, well, the only lens we should look at is evolutionary biology. Let's look for compounds that appear at unique junctures in human development, starting in early life. Let's see if there are any compounds there that appear sort of nowhere else. And we came across a library of compounds called human milk oligosaccharides in an infant nutrition lab. And the first thing I recognized, I said, well, these are not nutritional because they're amylase resistant. The body can't break them down for calories. So after fat and lactose, why is nature having human mothers produce these at an unprecedented diversity of structures and concentration? And furthermore, we also, at that same time, we're looking at, they're not just in milk. They actually enter maternal circulation during the first trimester, and they're in the fetal cord blood, and they're in the amniotic fluid. So literally from conception to several years out, literally encompassing the entire mother-infant dyad, and then, promoting the baby's, I'd say, foundational immune and microbiome programming after birth. So took a look at this and said, well, I don't have to develop a drug. Nature already did. I need to reintroduce it.
I love this, man. It's almost like you took the engineering approach in your career, right? And like me, you and I are similar in this. I've traveled an interesting path. I mean, it was biochemistry, psychology, functional medicine, transpersonal psychology, philosophy. And what's interesting about when you come at it from this perspective is you get people who are very integrative thinkers, right? So I always like to think about what is real intelligence. Well, it's not just gathering information. It's being able to put different pieces of information together in interesting and novel ways. And it's interesting how your story got here. And then you began to look at these compounds. So these human identical milk oligosaccharides, right? This is what you all do. And so this came from the human milk oligosaccharides. And I'm interested, you said a couple things there that I know I have a lot of practitioners listening. So let's just deal with this just for a minute. So these things are not being digested, right? Was what you hinted at here. So they're obviously being taken into the infant. They're also around, as you pointed out, prior to birth, but they're being taken into the infant. I assume the name human milk oligosaccharides, that they are very high in quantity in the mother's milk. And so the child is taking these compounds in. They are not being, digested in any way. And I'm assuming, since you mentioned they're found in the bloodstream of mothers as well, they are going intact into the system and having some type of major impact there. And given what you do, it seems that they are having an impact on the immune system. And we know that the gut and the microbiome of the gut is, the seat of the immune system. So this story is starting to get pretty interesting here, given that we know that the immune system is highly regulated and differentiated at the level of the gut. And now we have these compounds that seem to be acting right at this particular, sort of area. And so you have honed in on this area. Now, tell us a little bit about what exactly these things are doing. What do we know about them?
Yeah, it's a great question. And so what's nice, especially since I think a large portion of your audience probably is familiar with kind of plant-based oligosaccharides, they'll appreciate some of the nuanced differences in the mechanism here. So as you alluded to, there's definitely a systemic effect. One of the fascinating things that this is actually the sort of inception Sherlock Holmes moment of the company was there's been a long-standing observation that mothers with autoimmune conditions, rheumatoid arthritis, others, often during pregnancy, they go into remission, even though they're off their drugs, right? And so if you go back in history to the 90s, that actually was an observation that resulted in the search for something called substance X. And actually, the urine of pregnant women was fractionated and different compounds were isolated and, tested. And one of them, substance E, actually seemed to be effective on rheumatoid arthritis at the time when really there were no treatments. And that turned out to be cortisol. So that was a discovery of cortisol. It was synthesized as cortisone. They won I think it was a 1950 Nobel Prize for that. But if you actually read their laureate speech, they said, well, we actually didn't find substance X. We don't believe cortisone was that. But we found something that worked. And it's still a mainstay. Of course, it has some chronic side effects. But the aha moment was the same exact year, 2018, that I'm looking at these human milk oligosaccharides and understanding their mechanisms a little bit better. That was the same year it was discovered that they enter maternal circulation starting in the first trimester, which corresponds to when the historical observations of remission have been seen. At the same time, there was also a cohort that was it was an epidemiology study in Canada looking at 521 mothers, including some with existing RA, and they looked at ones that went into remission versus ones that did not. And the ones that did go into remission had a unique elevation in a specific human milk oligosaccharide in their milk, which corresponds to the levels in their serum. And the p-value is like 0.001. And then that formed a hypothesis, and they said, well, what if we put this in a mouse model of rheumatoid arthritis? What does it do? And lo and behold, it works, disease modifying. So that's one of the things that's unique is you have a prebiotic here that's entering the colon intact. It's the preferential substrate for bifidobacterium, right? But these work by very symbiotically with our symbiotes. They upregulate adhesion genes in the bifidobacterium so it can create a biofilm. They actually can break up existing biofilms as well. And then simultaneously, they're sugars, and sugars are a language that mediate a lot of intracellular responses, including pathogen-host interactions. Sugars on cells are doorways that are hacked by pathogens to enter the body. So some of these HMOs, they actually serve as soluble receptor decoys. So as they're terraforming that microbiome, you can have invasive E. coli, you can have H. pylori is binding to these instead of the baby's immature gut cells and being passed out. So that's how it disadvantages and really enables a healthy foundational microbiome to be formed. And then once that happens, as substrates for the commensal microbes, basically turns them into little drug factories. And they are just spewing a whole host of small molecules and metabolites, including like butyrate, of course, other short-chain fatty acids, and then even neuroprotective neurodevelopment compounds as well. And then to your point about the sort of direct immune modulating activities here, that's when things get interesting. So about like 1 to 4% of these do enter systemic circulation. I think it's kind of also the local juncture because these will get into the lumen, right? So they're getting into that area where, you have 70% of your immune cells. This is essentially the boot camp for the immune system. And they balance the immune responses with Th1, Th2. And we've actually seen that independent of any of the microbiome effects, so we can do it in completely a clean environment. We can change macrophage polarization from like a M1 to a regenerative M2 phenotype, also enhance Tregs as well. And it makes absolute sense. They're helping terraform the microbiome. The baby's immune system is being trained to recognize self, non-self, as well as friends, not friends. And so that's kind of how they work.
Yeah. And then, now I think the listener can understand why when I started looking into this, I got so excited because this is one of these things that works with the body's immune system and sort of the things that we have in place, our microbiome, to do what a healthy system would be doing anyway. Right. And so it's one of these things that I was just like, this is a really interesting set of mechanisms, not just one simple mechanism. Of course, one of the things that my medical background taught me right from the get-go is, sort of this integrated, holistic approach in both the approach of the practitioner, but in the way the body works. So many of these drugs that we take, they are big guns focused on one particular area. And this can cause downstream effects because our physiology is like, that spider's web. You touch one part of the web, everything else moves. And so having compounds like this that influence multiple aspects of immune function, from the bacteria to the actual cell membranes to actual immune cells, and modulating those cells is really incredibly fascinating. So I would imagine, and this is my next question, that for me, with knowing nothing else, I would be thinking about, obviously, autoimmune conditions. I would be thinking about allergic conditions, atopic conditions. Do we see that these things are having impact on these conditions? And to what extent are they? Is the research already there? Is this emerging research? But we can begin to guess that this could have far-reaching effects, even in things like cancer and other things like that. So I'm curious, what have you actually seen these compounds be able to do in terms of disease?
Yeah, it's a great question, and actually a really exciting one, because there is substantial preclinical data and sort of translational data suggesting that these can be disease modifying in the conditions that you mentioned. As I told you, the sort of genesis story is pretty fascinating because you have kind of a human epidemiology with a direct nexus to it. And that was then what I like about some of these studies is there's always a human epidemiology component, whether it's coming from mothers or infants, right? Because we can also look at infants that are formula fed, right? And there's also a human knockout model that's actually based on secretor status, on blood group, where some moms have a markedly different HMO profile in their milk, including one of the foundational ones. And what you can see is completely different trajectories in terms of health, and it corresponds to a different microbiome. And then you're able to do reverse translational. You're able to form a hypothesis and do a reverse translational experiment in mice, which is important for drug development, of course. And I think one of the other things, I like how you appreciate the kind of meandering path because you're right. It enables a different form of pattern recognition, and sort of a lack of bias, where you're like, I just want to find the truth behind something that's intriguing that no one's found the truth for, and it's not mine. I didn't invent it. There's a different responsibility associated with it. And, one of the things that is pretty annoying, quite frankly, to me, is the lack of translation of studies that are published in Nature, they're published in Science, they're published in Cell, and they don't make it. The biology just seems to peter out, usually after a company has raised a ton of money. And in the popular science media has already put out some articles saying these geniuses at these elite institutions may have found the cure for blank, right? Creating hope in patients, and it just never gets there.
Yeah.
And that's why when you look at the perverse statistics in the pharmaceutical field, they're saying now the cost to develop a drug is $3 billion. That tripled in the past decade. So this rebuts the solo residual, right? Wait, technology is supposed to make things cheaper and faster. Instead, it's longer and more expensive. And when something does get across the finish line, it's expensive to the system and it's really expensive to the patient. And oftentimes it has a mediocre profile at best. So that rant aside, it was saying, how do I remove that kind of translational risk? And there's a lot of reasons you can talk about it. Fraud is actually one of them. But a lot of it's the imperfect nature of animal models. Mouse models, especially when they're genetically manipulated. You're creating something that's essentially so artificial, it's designed to give you a conclusion that matches your hypothesis. So there's a subconscious bias that's been introduced even in preclinical proof of concept. So it's a long way of saying, guess what? These are not just human milk oligosaccharides. They're mammalian milk oligosaccharides. And so we've prioritized our initial candidates that we really want to kind of prove this thesis on based on ones that are common. So these are not artificial constructs. Is the biology preserved? So we're able to look at, every single different rheumatoid arthritis model. These work disease modifying. They've been tested against things like methotrexate, high dose methotrexate, a human mainstay, disease-modifying effects, reducing the systemic cytokines you want to see, but even promoting cartilage repair and even like pannus and bone erosion reductions, as well as edema, swelling. Same thing in atopic dermatitis models as well. And you see a reduction in the validated cytokines, the IL-4, IL-13, where we do have DMARDs. And importantly, these are all with oral dosing as well. So that's a profound improvement. Pardon me. The other aspect that's interesting is we're able to look at those in vivo experiments, and then we're taking the immune cells from those animals, doing some primary cell work, and then doing those same things with human cells as well, with the corresponding human cells, the monocytes and the T cells, and seeing basically the translation at the cellular level of the effects that led to the in vivo.
We'll be back after a quick break.
Why is it that we humans can't change when we want to change something? Why is it that when we want to change our health and fitness, when we want to be better with our finances, when we want to be better in personal relationships or find love, or we want to find meaning and have a life that makes more of a difference for ourselves and others, why is it that it's so hard to change? Well, the answer to that is because the entire industry of coaching and change psychology is built on willpower and habit change. And habit change and willpower can never work for one simple reason. It's our identities that drive how motivated we are, and it's our identity that drives our habits. In other words, if we change our identity, habits and motivation flow from that automatically. But if we try to approach it from a willpower, habit place first, we run into a dead end every single time. Now, every time you listen to this podcast, you hear about the 4 jobs every human must do. We must manage our finances and career. We must manage our health and fitness. We must give and receive love. And we must find our purpose and our meaning. We need to matter and make a difference as humans. The next level human coaching format helps you finally begin to embark on identity restructuring, to teach you how to reprogram the old stories that keep you stuck and tethered to an old identity. I'm inviting you to get involved with the brand new Next Level Human coaching platform. You can now be coached by myself and other Next Level Human trained coaches to finally begin to take advantage of this new science of quantum metabolism and identity restructuring. To get involved, all you have to do is go to www.nextlevelhuman.com/human-coaching. That's www.nextlevelhuman.com/human-coaching. And we will finally get you the change you've been looking for. I hope to see you there soon. Yeah, and just real quick, Alex, let me for the listener, for those of you who are getting a little bit lost with Alex talking about the science here, basically what he's essentially saying is as compounds go through sort of the rigor of seeing if they're going to be effective for a disease or diseases, they go through a process, usually in vitro, meaning in test tubes, petri dishes, that kind of thing, and then in animal studies prior to going into maybe human cells in petri dishes and things, and then finally into clinical studies. And so what Alex is walking us through right now is how this is going in sort of the in vitro animal world, showing that there are disease modifying effects. And the next step is going to be, and that's what's going to be the next question I was going to ask Alex, is do we yet have any in vivo or clinical trials unpublished in humans yet? And I think from what I heard you before, that's not yet the case, but maybe there is some of that going on. But the interesting thing is that, obviously these things have been in human milk since the beginning of humanity. They're in mammals. This is what he's talking about. And so we have an interesting way of looking at this, because this translational material, the in vitro studies, the animal studies, along with this idea of evolutionary biology, knowing that these things are there, makes this incredibly intriguing. And of course, one day we will get to hopefully clinical trials if, they're not here yet. But I just wanted to give everyone who's not skilled in the science of this a catch up to understand where Alex is with this. And then, Alex, do we have, and how far off are we off from sort of human trials with this? Is that stuff going on behind the scenes right now or not? Or can you even tell us?
Yeah, well, thanks, Jade. And first of all, thank you, and apologies to the audience. Sometimes I jump into my nerd hole.
I like. Don't worry, I like it, man. I like it.
And so thank you for offering that context. So one of the neat things here, and again, my premise was safety is an arbitrage opportunity, right? And so it was actually the infant nutrition companies that they've spent a lot of time. They've been working on this for decades, and part of that included, understanding, the safety profile of this. And so manufacturers of these compounds, of course, there's no human dairy out there. So these are being produced with synthetic biology. And so that pioneering work has occurred, and the manufacturers have demonstrated the bioequivalency. So it's equivalent to the natural thing, and that it's super safe.
Yeah. And let me just say something about that, because you and I know that people are going to ask this question as well. And just for those of you who are, again, not practitioners and concerned with this kind of stuff, whenever you hear things like, built in a lab or something like this, what a lot of people don't know is if you take vitamin C, for instance, and you take it from an orange, right? Like that vitamin C, and then you make vitamin C in the lab, those two vitamin C's are completely alike. Okay. So like they're basically the exact same thing. And a lot of people sort of get upset about this. All that's left is vitamin C. And so when we talk about, and I guess this is my next question, so these are bioequivalent. They are essentially the same thing. Is that what you're saying, Alex? That these are human identical, oligosaccharides, human milk identical oligosaccharides, so that while they are made in a lab, they are the exact same compound in terms of the way they function in the body. And that's what we're talking about here. But we cannot say that they're direct because, as Alex said, we don't have a dairy factory for human milk. And so these are being engineered in the lab in the same way insulin might be, sort of made in the lab. So.
Yeah, absolutely correct. Yeah, these are, and they're truly bioidentical. They're absolutely identical. And part of that's ethical, right? Because you can isolate this from donor milk, but then what you've done is you've diverted this from babies that need donor milk. So that it's something that's certainly important for us. There are some companies that are taking it from donor milk, and I disagree with that. So, and also that's a pooled. There are actually 200 distinct structures of these, and even ones that are same exact building blocks, but the bond angle is different on the structure, completely different bioactivity. So there's a ton of work to really understand what the merits of each structure are and what the applications are. And that actually leads to your question about where we are in terms of clinical studies. So safety has been established in human beings already, not long term, but long enough to get into like meaningful clinical studies. And we've met with FDA on that. And on the basis of that, we've been even approved in Australia to get into 2 different phase 2 clinical studies. And just so everyone knows, phase 1 is typically the safety studies. And that's usually in a healthy, normal volunteer population. And then a phase 2 is really kind of where the rubber meets the road, where for the first time you're putting the compound into a patient situation and seeing if not only is the safety preserved in that patient population, but does it do something that's clinically relevant to them. And so the lead compound that we are developing is the most abundant of these human milk oligosaccharides. So it's like 30%. If they're 200 different structures, this one is like 30% of the concentration. So it's really important for something. And as I mentioned, there is a human knockout model. What I mean by that is that some people have different genetics, so they don't produce this most abundant HMO in their milk. And that also corresponds to they don't produce a similar oligosaccharide that lines their mucosal tract, including like the GI, and it's identical. The oligosaccharide is identical between the milk and the one that lines their intestines and mucosal tracts. So those people that are missing this, they have a different microbiome, less bifidobacterium, and they get inflammatory bowel disease. So this compound is actually being tested at Cincinnati Children's Hospital right now in pediatric and young adult inflammatory bowel disease.
And is this 2FL? Is this the compound?
Yes. Yep.
Okay.
Yeah. So that's 2FL.
So this is fucosyl lactose.
Yes. Yeah.
How do you say that?
Yeah.
How do you say that?
Yeah. 2' fucosyl lactose.
Yeah.
Yeah. And so that's being assessed in that population. And interestingly enough, that at that same hospital, who's a partner of Intrinsic Medicine, they had a phase 2 that was a controlled study. It was actually the first controlled study. No one really knows about this study, so I really want to give them credit for it. It was in children and young adults that received bone marrow transplants. They got allogeneic bone marrow transplants. And these are really sick patients.
Yeah, no kidding.
And the prognosis for that has been known to be, because they're at risk of basically a graft rejection. You got a transplant with someone else's genes in it, the immune system can reject that and kill you, basically. So these transplant patients are put on tons of immunosuppressives, but there are still ones that get what's called it's like a steroid resistant acute graft versus host disease, where their body basically attacks the transplant. And unfortunately, like, the mortality is extremely high when you have that rejection and it's happening systemically, meaning in your GI tract or in your liver. And so, the scientists and clinicians taking care of these kids are saying, like, well, what determines whether someone gets that or not? And patients who have dysbiosis, makes sense. They have a dysregulated immune system as a result of that dysbiosis. So it's more primed to attack and cause this really severe and fatal consequence. So the hypothesis was, hey, we know 2FL can rescue dysbiosis. Maybe we can try it in these children and see if we can change that. And so they did that in a study. It was a controlled study. 25 patients received 2FL, 20 didn't. And not only were markers of the dysbiosis improved, but none of the patients that received FL had systemic acute graft versus host, compared to 4 in the control group that did not receive it. And the overall occurrence was very striking. Only one patient had a skin graft versus host in the 2FL, which is a mild one, which actually has a good prognosis. And in the controlled ones that didn't, it was 5 patients had 9 total occurrences. So you had patients that not only had systemic ones, but they also had the skin ones. So it was a full.
Yeah, so a small study, but a huge impact.
Huge impact.
2' fucosal lactose was having marked effect in these children.
Yeah. Yeah. And it was, and I think it would have seen a bit of wider recognition. Their p-value, if they were underpowered by a couple of patients.
Yeah. Yeah.
That's
their p-value. That's what I was thinking too.
Yeah. It was 0.07, which is is pretty darn close. Yeah. So they're off by a couple of patients, but we're still going to be talking to regulators about what we can do with that. No, I think that was an important study. And then, going on to the programs that we're running, we're actually getting ready to initiate a Parkinson's disease study in Australia at the beginning of next year with FEL. What's interesting here is this is really, I think Parkinson's is almost kind of like the prototypic gut-brain axis disorder. And it's really been in the past year that's come out in a striking way. I guess last summer, there's a 25,000 patient study. It was published in Gut BMJ. And it showed basically if you had constipation, your odds of getting Parkinson's are 400% higher than anyone else. And then I think just a couple of months ago in the JAMA network, another 10,000 patients published, same thing, constipation. Your risk of Parkinson's is, I think, 165.
Yeah, and you guys are all over this because I don't, the listeners, any of the practitioners know, anyone who's in functional medicine knows we've been talking for at least the last decade about, this gut-brain immune sort of axis and things like Parkinson's, especially Alzheimer's is the big one, even autism, ADHD. So this is a really big area, a huge area that actually is one of the areas, Alex, that I'm very excited about because obviously these are huge issues and we don't have a whole lot of treatment, things for these.
We'll be back after a quick break.
I want to talk to you about the coaching profession. Now, I know many of you listening are in the coaching profession or are healthcare providers, people like functional medicine docs, nutritionists, nurse practitioners, and others. And if you are, you probably have some of the frustrations that come along with doing that work. For example, how do we as coaches make true change for our clients? We know that information is not transformation, and we know that the models that we use are inadequate in many ways. If we just look at health and fitness, for example, 90+% of individuals trying to get healthy or lose weight, we know they fail, or they end up worse in the long run. And oftentimes this is the case even for people who are doing financial coaching or relationship coaching as well. Why though? Why is this the case? It happens to be that way because we are operating in a very old model when it comes to coaching. Currently, the coaching world is dominated by habit science and willpower strategies. But habits simply can't make the change we want them to because they are a consequence of our identity. In other words, habits flow out of identity. They don't create our identity. And there is a brand new science that explains exactly what the element and elements are that are going to create massive change through this identity restructuring. Quantum metabolism is the beginning of this new science. And no, this is not quantum mysticism. This is quantum metabolism. And this is the way that our biochemistry, our physiology sits on top of an energetic body. We now know that the biofield is real. Science has discovered and measured the old chakra systems. In other words, science is telling us that we can impact our physical body and our brain through the mental, emotional space of this biofield. Most of us think that habits drive change, but there's something below habitual actions, and that is our identity. And so in addition to this quantum metabolism and this identity restructuring technique, we can now begin to make drastic changes in behavior as a result of impacting this field. Now, I'm going to be training coaches in this new science of quantum metabolism and the techniques of identity restructuring so that we can finally have a model that is going to work for coaches and their clients and patients. And I would like to invite you to get involved. I am now taking individuals on the wait list for the Next Level Human coaching certification. If you'd like to get involved, all you have to do is go to www.nextlevelhuman.com/human-coach. That's www.nextlevelhuman.com/human-coach. Once you get there, I'm going to give you a free training to get you started and give you a taste of what this certification is going to be like. I hope I will see you there.
Yeah, and it's amazing that functional practitioners have been looking at this for so long, right? It's like it's been long recognized that the neurologists that see Parkinson's patients, they've said like, of course, yeah, all of our patients are constipated, and then you go into their histories and you're like, this has preceded any of their motor or neurological symptoms by years. So it represents, now that we're looking at this big data set, all of a sudden it's like constipation is a functional risk factor for these cognitive and neurodegenerative diseases. And it's something where, I think so many people have been trained in, I'm against risk factor medicine that's based on biomarkers. I think you scare people into doing something, and maybe you're budging a needle on a population-wide level, but that's looking at people as statistics. When even with things like statins, it's like, what are you doing in terms of the myalgia, the muscle pain, the insulin-resistant stuff? It's like
you and I are on the same page here, man. I've seen it. I just went through it with my father, actually. We put him on a statin recently, and he couldn't. I just took him right back off. Because it's just. So we're doing some. Actually, I'll give you one of my pet peeves about my field in functional medicine. One of the things, like we might have been talking about the gut-brain immune and the gut immune balance, but we're doing these treatments and dietary approaches, which I know I'm going to get in trouble with my fellow colleagues here, but they don't work most of the time for the things that we're really trying to help. Now, of course, we could make a strong argument they're working way better than what we were doing in the traditional realm. But this is what excites me about this style of medicine and this approach to finding solutions. And so obviously it's one of the things that excites me about you and your company and how you're approaching this, because I do think even the functional medicine world, yes, we may have been talking about this stuff, but our treatments and our gut restoration programs and just giving, probiotics and all the things, if we are going to be honest, and I think we have to be evidence-based, we have to realize that this is not being that effective for most people. Sure, it's more effective than not looking at this stuff, which the traditional medical world is not looking at this stuff at all, but it's also not that effective on the functional medicine side. Just a pet peeve of mine, I think it's important that we keep looking And rather than acting as if people in my field have figured this out just because we've been talking about it, I think we've been talking about it, but I don't think we figured it out.
Yeah. Yeah. And Jade, what I like to add to that is, again, I think it's like being constantly curious, having identified the problem. And then I think that's actually a good thing that there's an imperfect solution as well, because that will sort of truncate and shorten the diffusion of maybe a new practice standard from something where people can say, yeah, we've actually done, a probiotic approach. I mean, if you look at the trajectory on this, it started with the fecal microbiota transplants, and those demonstrated that, cool, you can therapeutically intervene at a systems level on the microbiome in a major way. I look at every single FMT study as a non-competitive proof of concept, because then there's always going to be a scaling issue, and there's some real infection issues. And also sometimes you achieve the effect on the disease, but then you change the phenotype of the person, right? Like, it actually shows how much that impacts things. And so what happened in terms of like microbiome treatments is, again, we're in the current state of medicine. You guys are the ones who are really breaking loose of it. But if we say the allopathic approach is a reductionist mechanical approach, not a systems approach, it's more biochem versus biology, which is an ecosystem and a system, and bidirectional, then it's saying, hey, what discrete components of that FMT led to that effects? And then all of a sudden you have limited consortia probiotics, and they're saying they're following the same thing, the association studies like GWAS, and say, oh, this bug is that one. And then they say, okay, let's isolate it. Let's introduce some antibiotic-resistant genes, because that's what we need to manufacture it. And, let's ignore the fact that this organism has a completely different time scale than a human being. And so it's effectively outside of the host for geological time periods. It's probably forgotten what it's like to be inside that host. And then it's reinserted, and you have engraftment liabilities. And that's not to say, probiotics are not without their merit, but it's probably an immunostimulatory. It's probably more of a transient, limited effect. And at the end of the day, where the field's going is it matters less about who's in there and more about what they're doing, right?
And I think what you're saying here, Alex, is so important for us as clinicians who are listening to this, and even those of you who are interested in this conversation, who are patients. This, what Alex just alluded to, in my mind, is the reason why you'll get all this marketing from different companies and different supplements, where the science is very exciting, but the translation into the actual product doesn't seem to have a huge effect. I can't tell you how many times I've seen new products come to market where people are like, oh my God, look at this amazing study and look at this thing we found. And then based on what Alex is telling us, how they come up with this in this very reductionistic approach and not understanding how to look at this in a holistic manner, you end up with a product or a program that is not that effective. And so I do think it's interesting where we currently are in medicine. It's all important, but this sort of reductionistic approach to this without the more holistic systemic approach is probably not going to get us there, which is why I get excited about where we're going here. So let me go ahead and wrap up with you and ask you, I mean, the first question everyone's going to ask, this is like, okay, where do I get this? How do I take this? What do I do with this, Alex?
Absolutely. And so, I always want to add something that's of value. So these are not broadly available yet. There are some companies that do have them. The quality control, the purity is certainly not up to our standards. So I'd say the announcement that I can make is, while we are a pharmaceutical company, while Intrinsic Medicine is a pharmaceutical company, I'm committed to making earlier access available for these compounds, given that they are safe. And so I will be starting kind of a parallel wellness company that offers these on a structure function basis. And initially, we will be launching in collaboration with a functional medicine clinic out of Chicago, and we'll be putting together a protocol of use case on this based on clinical data, including some positive data in all different forms of irritable bowel syndrome, and we'll be producing this at a clinical grade spec. And so, if people are interested in that, you can go to our current website, intrinsicmedicine.com, and just fill out the contact form, and then we'll update you on that one. And that's going to be primed for a Q1 launch. But we'll have material available.
So we don't have long to wait.
Yeah, so you don't have long to wait and then the way I envision things working between the companies is we'll be running like true pharmaceutical gold standard phase 2 clinical programs on the intrinsic medicine side, and on the intrinsic wellness side, practitioners within their scope of practice can actually look at those protocols and say, cool, do I want to do this on a case-by-case basis with my patients? And they'll have access to a high-quality spec material as well as practitioner-developed resources on the use of that. And that's kind of the way of saying that these compounds are for everyone. And I don't want to create excitement without providing access at the same time.
100%. Well, Alex, I have to say, man, I just want to say this podcast, right? It's called the Next Level Human Podcast. Part of the reason for that is that I believe that every single one of us are unique. There's never been another Jade. There's never been another Alex. There never will be. And your unique background and the way you came to this gives you the ability to do something that only you can do in the way that you can do it. And I really appreciate that you are doing it, Alex. I really appreciate you bringing this to the world. I think it's needed. I think you're just a brilliant dude, and you're doing like some really amazing stuff here. So I just want to say thank you for your work. Thank you for your time. Is there anything else you want to leave us with before we part ways?
Yeah. So thank you, Jade. It's been my pleasure. And, this has been a wonderful discussion. So I think there's a couple things. The first and foremost is that 95% of Americans are not at their dietary fiber levels. So that is a low-hanging opportunity for everyone to do an audit, for practitioners to do an audit. And, even though, the plant-based, the galacto-oligosaccharides, the fructo-oligosaccharides may not have the full profile, there's merit there. And of course, there's merit from whole foods, right? And so that's an opportunity for people to really profoundly shift their health and their microbiome. And so I don't want to disempower anyone and say, hey, you have to wait for the next scientific miracle. There's something that truly you can do today. And then I'd say the second thing is that I had a vision when I was starting this company and said, well, we would have entirely different drugs if every CEO founder was required to be the first one to take theirs. So, I'm not talking from a soapbox saying, hey, everyone else has to do this. I'm actually the person who has taken these chronically for the longest period of time. So I'm 4 years in, and it's constructively enabled me to cure my IBS-D, which was fairly debilitating. So, and same thing, my son had very severe atopic dermatitis. There was a milk allergy, and he was, kind of patient zero. And, we were able to get him from an EpiPen with 21 food allergies to eating peanut butter sandwiches,
Wow.
At the, between ages 2 and 4. So we're living it. And now it's about creating a data set that other people can use to inform their own use case. And of course, that's also what's driving me for sort of novel commercialization to create an early access opportunity, because I do believe in practice autonomy and then personal sovereignty for people to direct their own self-care and health and wellness journey.
100%.
So thank you so much, everyone, for listening. Jade, you for having me and the insightful conversation.
Yeah, my pleasure, Alex. Alex Martinez from Intrinsic Medicine.com. We appreciate you very much. You all go check out the website. And do me a favor, Alex, hang on the line just so I can make sure all this uploads.
Okay.
But for all of you, thank you for hanging out with Alex and me, and we will see you at the next show. You have been listening to the Next Level Human podcast with Dr. Jade Teta. If you enjoyed this episode, please make sure you subscribe and consider leaving a review. You make the biggest difference when you pass on your lessons and inspire others. That's why reviews like this are so powerful. Your words may be the only ones that resonate for someone else. Please remember the information in this podcast is for educational purposes only. Always consult your personal physician or therapist before making any lifestyle changes. And finally, thank you for who you are in the world and the difference you make.